Okay, take 419 is finding the antiderivatives of the trigonometric and hyperbolic functions. So let's look at derivatives to start with so we understand how easy this is going to be. So the derivative of the sine of an angle is the cosine of the angle times the derivative of the angle. Okay. So the derivative of sine is cosine. Therefore, the integration or the antiderivative of cosine is sine. This is the way you know all these, by just knowing your derivatives. So the integration or antiderivative of cosine is sine. And this is true for hyperbolics too. Okay. Basic rule, the plus and minus signs change up a little, but still, the antiderivative of cosine is sine. The antiderivative of sine is minus cosine. The antiderivative of secant squared is tangent. The antiderivative of cosecant squared is minus cotangent. The antiderivative of secant tangent is secant. And the antiderivative of cosecant cotangent is negative cosecant. Watch. If you have the integration of tangent, it's not one of these. If you're looking for the antiderivative of tangent, it's not one of these. We have to learn how to do that a different way. So don't get that fouled up now. The derivative of tangent is secant squared, but the antiderivative of tangent is not one of the memorization rules. Okay, so now let's go and look at a bunch of individual cases. Okay, the antiderivative of the sine of 3x is, we must have the derivative of the angle in here. So we must put a 3 and put a 1/3 out in front. So the answer is 1/3 cosine of 3x plus c. Wait a minute, that's a negative because the derivative of cosine is a minus sine. Now, you shouldn't have to have an answer in the back of the book to know whether you're right. All you have to do is take the derivative of these. The derivative of cosine is sine. The derivative of the angle is 3, that divides that out. Oh, I'm sorry. The derivative of cosine is a minus sine, so this minus times a minus makes it a plus. Okay, next one. Okay, this looks like we have a product here, but we really don't, because what happens is we're trying to find the antiderivative of the cosine. The antiderivative of cosine is sine if we have the derivative of the angle. The derivative of the angle is 4x, so we'll put a 4 there and a 1/4 out in front. So my answer is 1/4 sine of the angle. All right, next one. The antiderivative of secant squared is tangent. So that's the easy one. And the reason we know that's true is because the derivative of tangent is secant squared. So we did it right. All right, next one. The antiderivative of cosecant squared is cotangent. However, it's a negative. The derivative of cotangent is negative cosecant. So in other words, we need to put a minus in here, a minus out front, and so that works. Again, don't forget to put plus c on antiderivatives. These are called indefinite intervals. Okay, if you don't have limits, then you're supposed to have a plus c. Okay, next one. Now, memory, power rule, log rule, all these different things. So what this is a power rule. This is the same thing as the sine of 3x squared. What is the derivative of sine? It's cosine. So this is the derivative inside the parentheses. Therefore, it's the power rule of the parentheses. But now don't forget, anytime you take a derivative or integration, you've got to have the derivative angle, which is a 3. So in front, I'll have another 1 over 3. So final answer on here then would be sine cubed of 3x over 9 plus c. Power rule. Power rule. At this point in your knowledge of finding these things in the textbook, you don't have anything but the power rule. You don't have a product rule for integration. There's no such animal as a product rule for antiderivatives yet until you find integration of parts. Okay, so I have to change it to what I need. Okay, next one, power rule. This is simply the tangent to the 6th power over 6 because this is the derivative of tangent. Okay? Next one. Now the next one is one we have to, the next several now, we have to make it work out for us. So what we'll do in this one is rewrite this as secant squares, split one secant off. And what we have now is the derivative of the secant. Forget the square for a minute. We have the derivative secant, therefore this is the power rule. Okay. So if you ever have a secant to the 5th power times a single tangent, then you split one of these off, and it ends up coming back to the 5th power. But it's a power rule. You're looking for its derivative inside. All right. Next one. Antiderivative of tangent. Well, there's not any rule where we take the derivative of and get tangent. So what we have to do in this one is change it to sine over cosine. And so it becomes minus the log of cosine. I changed it to have a denominator. What is the derivative of the denominator? The derivative of cosine is minus sine. So it's the log of the denominator because this is the derivative of the denominator. So it becomes a log rule. Same thing with cotangent, it simply becomes the log of sine. Because cotangent is cosine over sine. Cosine over sine. The derivative of sine is positive cosine, so it's a positive log of the denominator. Now I need to go back to the one before that. I need to talk about this. You will see in the textbook a lot of times, or answers in the back of the book sometimes, this will be written as the log of the secant x. And all they're doing is moving this minus power in here and writing the cosine to be 1 over the cosine, which is the reciprocal, which is secant. Okay, now let's go to the next one. The integration of secant is just something you need to memorize, okay? Because you're going to have this several times when you go into trig substitution, basically that one. Okay? But you'll encounter this several places, and especially if you encounter differential equations. So just one to memorize, and that's the way it is. And the way you find out now is if you go take the derivative of this and get it simplified, it ends up being back to secant. Okay, then that's kind of gives you an idea of power rules and splitting and making it work out for the integration of the basic trig function. Now the next examples the next 4 examples, I want to say, look, let's look at these and just show it's the same stuff. Hyperbolic sine is the same as sine. It's the same rules, except sometimes plus and minus signs. So the antiderivative of hyperbolic sine is hyperbolic cosine. And it's positive because hyperbolic cosine derivative is a positive sign. The way I try to tell my students is, in regular trig, it's cosine, cotangent, cosecant are negatives. The co-functions are negatives. Whereas in hyperbolics, the first three are positive, the last three are negative. So cotangent, hyperbolic secant, hyperbolic cosecant are negatives. The first three are positives. All right, don't forget though, we must have a derivative of the object right here, so we need to have a 1/2. Okay, and I'll work some more, but I'm just saying to you, hey, you got the rules now for the antiderivatives of hyperbolic functions. So look at the next example. Is I need the derivative of this thing right here, so I need a 1/5 of the problem and a 5 out front. All right, next one. The antiderivative of hyperbolic tangent, same as trig. You need to change this to hyperbolic sine over hyperbolic cosine. Therefore, the answer is positive, the log of hyperbolic cosine. And cotangent would be positive, the log of hyperbolic sine. Okay, now let's look at some really involved looking problems. They're not necessarily that much harder, but they sure look harder. So let's look at those.
Starting at 10? Yes, 12.
All right, let's look at this one now. It looks like a complicated problem. It looks like a secant and tangent and hyperbolic sine, but it's not. It's nothing but hyperbolic sine. The antiderivative of hyperbolic sine is hyperbolic cosine. Of whatever this thing is, if you have that the derivative, there it is. So the derivative of this object right here is that, therefore this is simply hyperbolic cosine of that. That's all there is to it. In other words, if you have a hyperbolic sine or cosine or a regular tangent or something, look for the regular memorization rule of that. And see if everything around it is the derivative of what we might want to call the angle. This is not an angle. Okay, next one. Right. The integration of hyperbolic cosine is hyperbolic sine. What is the derivative of this? There it is, 1 over x. Just the antiderivative of hyperbolic cosine is hyperbolic sine. If I have the derivative of the object right here, I do, therefore it's there. That's it. All there is to it. Next one. Next one is power rule. This is the derivative of hyperbolic tangent. Therefore, this is simply the power rule of hyperbolic tangent. This is the derivative of hyperbolic tangent. So therefore it's the power rule of hyperbolic tangent. Right, next one. Power rule. This is the derivative of hyperbolic sine. Therefore it is the power rule next one. Right. Is itself. Okay. The integration of e to some power is itself. If I have the derivative of the power, sure enough, there it is. The derivative of the power is we have, therefore it's itself. Okay, now the next one is where it starts getting complicated, because this is not the derivative of the other one, and so forth. So, in a regular class period of time, I show the identities on hyperbolics to say sometimes what you have to do with these is change hyperbolic functions over to the e to the x definition of what they are, and then go working. So 2's drop out, and e to the x times e to the x is e to the 2x, and e to the x times e to the minus x is 1, and that makes the problem very easy. The integration of this is 1/2 e to the 2x minus x. So this problem, as you point out a few times, you have to change these things over to the definition of what hyperbolic functions are in terms of e to the x's, and then work it from there. All right, next one. Same thing happens on this one. Okay. So what we need to do first is go e to the x plus e to the minus x over 2 plus e to the x minus e to the minus x over 2, all up to the 4th power. And now when you add those, look what happens when you add those. These drop out, and you end up with 2 e to the x over 2. All that's to the 4th power. And so what we have is the integration of e to the 4x. And so that ends up being 1/4 itself. Okay. This concludes in the table on this. I hope this gives you the beginning concepts of integration of trigs and hyperbolics, and how you change them to power rules or log rules or whatever